Welcome to this explainer. I am super excited to dive into this with you guys today. We're going on a fascinating journey into the future, but honestly, it's a future that's already unfolding right in our living rooms and offices. We hear these buzzwords literally all the time, right? Augmented reality, virtual reality, mixed reality. But what do they actually mean? Where does one end and the other begin? Well, today, we're going to completely demystify these realities. Drawing straight from Chapter 5 of our source material, we're going to break down their unique definitions, figure out exactly how immersive they really are, and peek under the hood at the incredible hardware that makes them tick. Here is our quick roadmap. First, the reality-virtuality continuum. Next, we'll break down augmented, virtual, and mixed reality. And finally, we'll wrap up by comparing the hardware differences. All right, Section 1. The reality-virtuality continuum. Let's map out exactly where these technologies sit. Think of this like a giant sliding scale. What we're looking at here is Paul Milgram's reality-virtuality continuum. These tech concepts aren't just completely isolated buckets. They exist on a spectrum. On the far left, you've got your real environment. That's the physical, 100% tangible world where you're sitting right now. And all the way on the far right, we have the virtual environment, which is a completely synthetic, computer-generated world. Basically, everything we're talking about today is just a matter of where you slide the dial on this exact continuum. Moving right along to Section 2, Augmented Reality. Let's nudge that dial just a little bit to the right and see how we can enhance the real world. So, the biggest takeaway here is this. Augmented reality is definitely not replacing your world. It's just upgrading it. AR gives you a live view of your physical environment, but it's supplemented, or, augmented, with digital stuff in real time. Think GPS data, 3D graphics, or video just layered perfectly over what you're already seeing. You're still fully present in reality, just with an incredibly cool digital layer slopped on top. A classic example of this that we've probably all tried is Pokémon Go, or even those Snapchat filters. The user is looking at an actual, literal physical sidewalk through their phone's camera, but the software basically just drops a digital creature right there on the concrete. The real world is your canvas, and the digital content? That's just the paint. Okay, Section 3, Virtual Reality or VR. Let's grab that dial and crank it all the way to the far right edge of the continuum. We are leaving the physical world behind. Now, unlike AR, which just gives you that extra layer, VR is completely isolating. Virtual reality creates a fully immersive, completely computer-simulated world. It literally cuts off your vision and hearing from the physical room you're in and transports you to an entirely imaginary 3D landscape. It is totally designed to trick your brain into genuinely believing you are somewhere else. You can really see that total immersion right here. The user is entirely blocked off from reality by that head-mounted display. And in a high-end VR setup, you aren't just blindly staring at a screen. You're actually moving around, hearing realistic spatial sounds, and using haptic controllers to grab and manipulate objects within that totally artificial space. It's wild. Her senses are engaged exactly as if she were truly standing inside that digital landscape. But to pull off that kind of trickery, you absolutely need the right hardware. On one end of the spectrum, you have high-end gear like the Oculus Rift, HTC Vive, or PlayStation VR, which usually need to be tethered to a beefy PC or console to render all those complex graphics. But then, on the flip side, you have these incredibly accessible entry points, things like Google Cardboard. With these, you just slide your everyday smartphone right in to act as this screen, load up a 360-degree video, and boom, instant immersive environment. All right, on to Section 4, Mixed Reality. We've seen digital layers, we've seen total immersion. Now let's see how this builds into the ultimate hybrid experience. Mixed reality, or MR, sometimes folks call it hybrid reality, is where things get truly mind-bending. It is the true merging of the real and virtual worlds. But the absolute game changer here, the thing that totally separates MR from basic AR, is real-time interaction. Physical and digital objects don't just awkwardly sit on top of each other. They genuinely coexist and react. Picture this. You're playing a video game in your living room. You pick up your actual physical water bottle and you use it to physically block an imaginary laser beam. That is mixed reality. Imagination and reality have literally never been so intermingled. This is a brilliant example of what that looks like in a highly professional space. These engineers are wearing advanced headsets, but they aren't closed off in some virtual bubble. They can see the physical desk, they can see each other, but they are also manipulating this incredibly complex digital robotic arm that is seamlessly integrated into their actual room.
They're interacting with a synthetic 3D model exactly as if it were heavy machinery sitting right in front of them.
And it's just as amazing for entertainment. Look at this user basically standing with one foot in reality and the other in a digital playground. The digital game elements are genuinely interacting with the actual living room furniture. Characters can hide behind a real sofa or jump up onto a physical coffee table. MR is fundamentally breaking down the basic rules of what is a real physical object and what is just synthetic code.
Which brings us to Section 5, the hardware differences. Having defined these three distinct technologies, we have to ask, what kind of engines are actually powering these realities?
Well, the contrast is pretty huge. We can easily see the supreme accessibility of augmented reality compared to the demanding requirements of virtual reality. Because AR usually just overlays basic 2D or 3D graphics onto a camera feed, it can run on almost every ubiquitous modern smartphone out there. VR, on the other hand, demands complete isolation. It requires specialized, completely enclosed headsets, noise-canceling headphones, and usually a whole setup of external cameras or sensors just to track your physical boundaries so you don't walk into a wall.
But when we get to mixed reality, the hardware requirements absolutely explode. And frankly, this is exactly why MR hasn't quite hit the mainstream consumer market yet. Devices like the Microsoft HoloLens retail for over $2,000. That's 3 or 4 times the price of a top-tier VR headset. Why? Because to make digital and physical worlds react to each other, the headset needs insane processing power to constantly map your entire physical room in real time. It requires built-in cameras, advanced depth sensors, binaural sound, and an inertial measurement unit to flawlessly track your head movement. Microsoft literally had to invent a brand new chip, a holographic processing unit, just to handle all the math required to understand your gestures and where you're looking.
If you're taking notes, this is your screenshot this moment right here. It is the perfect summary of how AR, VR, and MR compare. AR gives you low immersion, but you just use the smartphone already in your pocket. VR gives you total, high immersion, totally replacing the real world, but you're tethered to a specialized headset. And MR? It sits right in that sweet spot, a medium, hybrid immersion that allows for incredibly high real-world interaction, but it absolutely comes at the cost of requiring highly advanced, super expensive headsets.
To wrap up this explainer today, I want to leave you with a final thought to chew on. We've seen how distinct AR, VR, and MR are right now, largely because the hardware forces them to be. But as that hardware continues to inevitably shrink down to the size of normal eyeglasses, and as processing power continues to just absolutely explode, the lines on Milgram's continuum are going to blur permanently. When you can jump seamlessly from physical to augmented to mixed to entirely virtual, which reality is ultimately going to claim the most of your daily life? Thanks so much for exploring with me today, and keep learning.